Hello everyone and welcome back. My name is Mr. Kowalt, and in this video I will be going over how to find the equilibrium concentrations when all you're given in the problem is your balanced equation and the equilibrium constant along with everything, all the equilibrium concentrations except for one thing, right? So you're missing the equilibrium concentration of one product or one reactant. And so how would you do that? How would you figure out the missing equilibrium concentration? Well, well, the first thing you want to do is you want to write down the equilibrium constant expression for the equation. So for this one, your Kc, right, your Kc expression would be equal to, again, products over reactants, so CF4. So it's going to be the concentration of CF4 raised to the 1 power because of the coefficient of 1 multiplied by CO2 raised to the power of 1 because we have coefficient 1. And then we have 2 COF2, so that's going to be the concentration of COF2 to the power of 2. All right, so we know our Kc, we're given Kc, which is 2.00 at 1,000 degrees Celsius. And we're given the concentration of 0.255 molar and 0.11 molar at equilibrium. So these are at equilibrium. That's what the problem is giving me. So if this is the case, then I can put the concentrations in for these two here and solve for CO2, and then I have my answer. So then I can solve this equation for CO2, so this, the concentration of CO2 then becomes equal to Kc multiplied by, COF2 squared divided by the concentration of CO2. That'd be the concentration of CF4. CF4. Okay? So then all I need to do is plug in the values for Kc. So then this becomes, so let me go ahead and erase, I'll erase this. Okay, so then I have CO2 is equal to, and then Kc, I have 2.00 times COF2, the concentration of CFO2 squared, right? So it's going to be 0.255 squared over CF4, that's going to be 0.118 molar. And then all I need to do is calculate it on my calculator. And so this becomes equal to 1.10. So 1.10 molar is the equilibrium concentration for CO2. And that's how you solve this sort of problem. So again, the problem is I am given my K value, the equilibrium constant. I'm given everything, all the equilibrium concentrations except for one. So I just plug it into my equation, my expression for Kc, solve for the missing part, and then plug in the numbers and calculate. Let's do the same thing for number 2. So in this problem, again, I have the equilibrium concentration for I2, but I don't know the equilibrium concentration for I. But I am given the K value. So let's write down the expression for Kc. So for this reaction, it's going to be products over reactants. So it's going to be the concentration of iodine atoms squared because of the coefficient 2, and then over I2. So the concentration of I2, iodine, to the first power. And so here's my expression. So again, I know the Kc, I know the equilibrium concentration for I2, so I can solve for I. And so if I solve for I, then K, So if I solve for, I'm going to solve for I. So I'm going to solve for the concentration of I. So the concentration of I is going to be equal to Kc multiplied by the concentration of I2. But then because there's a square there, I have to square root this. So here's my expression for I, for the concentration of I. And so all I need to do is plug in the values and calculate. So then this becomes the square root of Kc, which is 0.011 multiplied by the concentration of I2, which is 0.01. And so I just plug that into my calculator. So the answer is 0.0105. So that's going to be 0.01105 molar, or 0.011 molar for the concentration of I. And so that's how you answer these sorts of problems. I hope you found this interesting, and if you like this video, please like, share, subscribe, and hit the notification bell. Thanks for joining me, and I'll see you next time.